Maths Masterclass with Leo. Let me teach you a bit of math.
Let me teach you a bit of math, okay?
In this channel, we'll be dealing with learners who are in grade 10, grade 11 and grade 12. We'll be dealing with learners who are below average, average and above average. Actually, when you talk about learners who are below average, you're talking about from level 1 to level 3 learners. Average, you're talking about level 3 to level 4. And then above average, you're talking about level 5 to level 7. We'll also be dealing with learners who want to rewrite maths. They've been struggling with maths. And then we'll be dealing with ways to answer questions, how to attempt questions, how to actually pass maths. And then we'll be dealing with question papers, paper 1 and paper 2. You know those simple chapters in paper 1 when you talk about the average learners or below average learners. You know those questions. And then when we talk about paper 2, you know those questions, you know those chapters, statistics, and so forth and so on. Maths Masterclass with Leo. Today we will be doing quadratic patterns. On our last class we did linear patterns. Today we will be doing quadratic patterns. Okay, before we do quadratic patterns, I have a question which is a linear question, which is it's from a linear pattern that is most likely to come from your exam. These are the questions that you should expect from your exams, right? Because they will never ask you those simple, straightforward questions. You're given a question like this, they tell you this is a linear pattern. This is a linear pattern. Okay, now you need to calculate. What do you need to calculate? You need to calculate term number 4 and term number 5. You need to calculate the value of T4 and the value of T5. Right? These are the values that you need to calculate. But you know that you can never calculate the value of T4 and T5 if you do not have the value of X. Right? So you need to calculate the value of X first. You're going to calculate it and say, okay, D2 equals to T2 minus T1. This is how I can calculate it. Or I can just say, let me not say D2, let me say D. D is equals to T3 minus T2. Right? This is how I can calculate them. Right? Okay, this can be my first equation. This can be my second equation. Why do I say first equation and second equation? I'm going to have two unknowns. Which are the two unknowns? I'm going to have D, which is unknown. I don't know it. And then I'm going to have X as well, which is unknown. I need to calculate it. Okay, let me show you what am I trying to show you. Okay, I'll say I have 5 minus X, which is my T2 minus my T1 minus into X minus 1, close bracket. I'm going to have 5 minus X, negative and positive is going to be negative X, negative and positive, and negative is going to be positive 1. This will give me 6 minus 2X. You see, I have an unknown, which is X. I have another unknown, which is D. Okay, let's go to the next one. I can just say D is equal to T3 minus T2. Now, what is my T3? My T3 is 3X minus 1 minus into 5 minus X. See, then this will give me 3X minus 1 minus 5 plus X, because negative and positive, negative, negative and negative, positive. Now, I'm going to have 3X, and this will give me 4X minus 6. There. As I said, this is my first equation, this is my second equation. But I can just equate the equations. I can just equate both the equations because I have the value of D, I have the value of D. I can say this equation equals to that equation, right? Equate D is equals to D, right? I'm going to have 4X minus 6 is equals to 6 minus 2X. There. Then group the like terms. 4X plus 2X is equals to 6 plus 6. This will give me 6X is equals to 12. Right? Then X is equals to 2. When you divide it both sides by 6, you're going to have 2. Right? Then now, since I got the value of X, I can substitute it where? On my equations, I have X minus 1 is to 5 minus X is to 3X minus 1. I can substitute it here on my pattern. Then I have 2 minus 1. I have 5 minus 2. I have 3 into 2 minus 1. This, I believe, will give me 1 this will give me 3, and that will give me what is this? It's gonna be 5, I believe, because it's 6 minus 1. Yes, it's 5. Now if you have something like this, now this is the pattern that I know. They said calculate or determine the next two terms, which is term number 4 and term number 5, right? Then I can calculate the difference and say, oh, what is my difference? 3 minus 1. Oh, my difference is 2. 5 minus 3, my difference is 2. Okay, now I have the difference. I have the third term. I'll say my difference plus my third term, my difference plus my third term, it will give me term number 4, which is what is it? I think it's 7. I believe it's 7, right? And then again, this minus this, it's 2, right? Then I have this one. I need the fourth term. I mean term number 5, because I got the fourth term. So I'll just say my difference plus term number 4, it will give me term number 5. Why do I say that? Remember good people, remember that D is equals to T. Okay, let me just say 1, 2, 3, 4. D is equals to T4 minus T3, right? But I have the value of D. What is the value of D? It's 2. Plus I have T3. What is T3? It's 5. 5 plus 2 is equals to T4. T4 is equals to 7. This is how I'm getting these things. That is why you see me saying, or you hear me saying, this plus this will give me this. Difference plus term number 4 will give me term number 5. Difference plus term number 5 will give me term number 6. And so forth and so forth. You see, in this case, I have term number 4. 1, 2, 3, 4. I have term number 4. I'll add it with my difference. It will give me T5. What is my T5? T5 is equals to 9. There. T5 is equals to 9. If I say this and this, it will give me 2. Now, let's go to the real business of the day. Quadratic. We talked about quadratic patterns. We said today we are supposed to do quadratic patterns. Hope you understand this one, where you need to solve it, or where you need to get the value of x before you rewrite your pattern, and then after rewriting your pattern, you get the next two terms that they want you to get. Okay, before we continue, please don't forget to subscribe to my channel to get more videos like this one. And yeah, let's continue. We are doing quadratic pattern, right there. Then remember the quadratic formula, or the quadratic equation, not the formula, the general quadratic equation. It's ax squared plus bx plus c. This is the general formula for quadratic, ne? And then, but we are talking about patterns, and we need to write it as an equation. Tn is equals to an squared plus bn plus c, right? And then now, whenever they say write the general or the nth term, calculate the nth term or determine the nth term, what do you need to calculate? You need to calculate the value of a, the value of b, and the value of c, so that you can write it or substitute them on your equation. How do I calculate that? I can calculate them by saying, okay, d2 is equals to 2a, right? d2 is equals to 2a, or the second common difference is equals to 2a, right? And then d1 equals to 3a plus b. If ever I use this formula, mind you, I would have calculated the value of a here. After calculating the value of a here, I'll substitute it here and then get the value of b, because I'll be having the first difference, right? And then after that, after getting the value of a and the value of b, I can just substitute them here and say a plus b plus c is equals to my first term, right? I would have calculated this, and I would be knowing my first term, and then I'll be able to calculate the value of c. I hope you understand. Let's go to the question. The question, we are given the following pattern, which is 1, 3, 7, and 13. You're given this pattern. This is 3 actually. Yeah, you're given the this pattern and they say calculate or determine the next two terms, right? How am I gonna determine the next two terms? I'm gonna say, oh, this one, I'll say, oh, this and this, it will give me my this and this, it is 2, this and this, it is 4, this and this, it is 6, right? Oh, now this is my first difference. So, oh, what they were saying, 3a plus b is equals to this. Okay, this is d. Actually, this is d1, right? Okay, now that you see d1, your first common difference, it is your linear, right? It is now a linear pattern. Now I'm gonna say this minus this minus this is 2, this minus this, it's 2, right? Oh, when they say 2a is equals to d, they mean 2a is equals to that. That is d2, right? Oh, but they said calculate the next two terms without calculating or without getting your general or your formula. You can easily calculate this. Let me show you how. You're going to say, let me show you an example. How did they arrive here? How did they come to this one and this one? You are given this, right? You are given, you need to know how did they get 7. Okay, they got 7 by saying 3 plus 2 plus 2 is equals to 7, because this and this is 4 and that is 7. Now, how did they come to 13? How did they come here? Oh, they said this. Okay, now, how did they get 13? They said this plus this, it gives them 13, right? We need a number that will come here. We need a number that will come here and here. Come, I tell you, this is a pattern. If you can check, you have 2, 4, 6. The next number, 8. The next one, 10. Right? So I'm going to say, oh, 6 plus 13 is going to give me this one. What is 6 plus 13? I believe 6 plus 13, it will give me 19. Right? When you say 19 minus 13, it gives you... what did I do? No, I made a mistake. It should be 13 plus 8, not 13 plus 6. 13 plus 8, it will give you, I believe, 13 plus 8, 21. Let's just prove it. Make sure 13 plus 8. Yes, that's 21. Now, for them to move from this one to this one, they said 21 plus 10. It will give them 81. Right? Now, when you say this minus this is 2, this minus this is 2. Right? Then now, let's move to the next question. We have calculated the next two terms, which are 21 and 31. Let's move to the next question. The next question says, okay, here we are supposed to calculate the next two terms. Let me just write it, next two terms. There, the next two terms. These are our next two terms. The next question says we need to determine the nth term. Nth term, which is the general formula or the formula. Determine the nth term. When they say determine the nth term, they mean determine this. When they say determine the nth term, right? Now, how am I going to determine the nth term? Remember those things that we were talking about. 2a is equals to d2, right? What is my d2? My d2, 2a is equals to 2, right? Divide by 2, a is equals to 1. There, right? Okay, always when you use this formula that says 2a is equals to d2, 3a plus b is equals to take these ones, take this, and take this. Always take the first terms that you got. Take these ones. Never take these ones, because they have their own formula. Do not, I say never, take this one. This one's take this one, and that one, because this is their formula. Take this one, and this one. Do not take these ones going that side. Just take these ones, right? Because these are the formula that represents this one, the first one, the first one, and the first one. Right? Okay, now we have calculated the value of A. Remember, if we have the value of A, we can just say 3A plus B equals to D1. 3 into 1, this is the value of A, plus B is equals to, what is that? There is a 2. Because I'm taking which one? This one. Right? And then I'm going to say 3B is equals to 2 minus 3. This will just give me negative 1. Right? Then I can just say A plus B plus C is equals to T1 or term number 1. Then what is A is 1. Plus what is B? B is into negative 1 plus C is equals to, if you remember, the value of A or T1 is 1. There. Then this is negative plus 1 minus 1 plus C is equals to 1. This is 0 plus C is equals to 1. Now C is equals to 1, you can see. Now let's come back. I'm going to say Tn is equals to, what is the value of A? It's 1, but I can just write n squared. What is the value of B? It's negative 1. I can just write negative n. Then what is the value of C? It's plus 1. Now that is my general formula. If you want to prove it, you can just say where I need to get the following terms. 1, 3, 7, 13. Term number 1, 1 squared minus 1 plus 1. You see, the first term, I'm getting 1. Second term, substitute 2. Second term. See, the second term is 3. Third term, 3, 7. Fourth, okay, let's just take term number 5, 21. Term number 6, 31. Right there. Then let's take the next question. Okay, the next question says, what is the 20th term? Right? This, good people, this is a position. Remember, if you don't understand or you don't know what is a position, go to the first lesson number 6, where we're explaining linear patterns. Position, it is represented by the value of n. When they say the 20th term, they are talking about the position, right? So in this case, we have our formula that says Tn is equals to n squared minus n plus 1, right? Where there's n, I need to substitute 20, because this represents a position. In position 20, what is our Tn? Right? In position 20, what is our term? Okay, so we need our term in position 20. So I'm just going to say T20 is equals to into 20 squared minus 20 plus 1. Right? Then I'm going to say, what is 20 and then 20? What am I getting? 381. In position 20, I have term number 381. In position 20, I have term number 381. Right? The next question says we need to, which term is 57? Which term is 57? Now, what are we looking for? We are looking for the position. We're looking for the value of n. Right? In which position can we get this term? Term number 57. Right? I'm going to say, okay, I have term number 57. Remember, Tn represents a term. So I have term number 57 is equals to n squared minus n plus 1, right? Then group the like terms. I'm going to have n squared minus n plus 1 minus 57, right? Then I'm going to have n squared minus n, okay, minus n, this is minus 56, I believe, is equals to 0, right? Now we need to factorize or use a quadratic formula for this one, but I'm gonna use factorize just to save time. Okay, yeah, I factorized it and got, if I say negative 8 plus 7 is gonna give me negative 1. When I say negative 8 multiply positive 7 is gonna give me 56, which is negative, ne? And then now n minus 8 is equals to 0, n plus 7 equals to 0. N is equals to 8. N can never be negative 7. Why? N can never be a positive, a fraction or negative. N cannot be less than 0. N cannot be less than 0. Okay, n cannot be negative, right? N cannot be negative. There, let's just prove if our answer is correct. Let's just take 8 squared minus 8 plus 1, 57. There, I believe we are done with this. And then I'm gonna check a question paper. Let me just check a question paper and try to answer one question. Okay, this is the question, the last question of the day. We are given the following statement that reads as follows. The first 4 quadratic patterns are 15, 29, 41, and 51. Mind you, this is from 2019 June exam. They say write the value of the 5th term. That is the first question. The second question, the nth term of the pattern or the general term. And then the third question, you are supposed to calculate T27, right? Okay, this one you can get it by saying, okay, this minus this is 14, 41 minus 29 is 12, 51 minus 41 is 10. I need the number, a number that when I subtract it with 8, it will give me 51, right? A number that when I subtract with 8, it will give me 51. I can get it by saying 51 plus 8, it is equals to 59. When I subtract 59 and 8, it will give me 51, right? Now let's continue. I need, this is my 5th term. This is my 5th term is equals to 59. Right? Now, the second question says we need to calculate this, the nth term. But I can calculate the nth term if I know the second common difference, right? If I know the second common difference, this now it's a linear pattern. When I say 12 minus this is giving me 2. When I say 10 minus 12, it's 2 again. When I say 8 minus 10, it's negative 2. These are supposed to be negatives, all of them, because 12 minus 14, it's negative 2. 10 minus 12, it's negative 2. 8 minus 10, it's negative 2. So now it means I can say, remember, 2a is equals to d2. Now, 2a is equals to negative 2 because the value of d here is negative 2. Then divide by negative 2, divide by 2, divide by 2, a is equals to negative 1. Now, I need the value of b. I can get the value of b by saying 3a plus b equals to d1. Then now, 3 into negative 1 plus b is equals to, this will give me, it's this one, negative 4, positive 14. Then this is negative 3 plus b is equals to 14. Then b is equals to 17, because this, if I take it to the other side, it's going to be positive. Now I need a plus b plus c is equals to t1. Then what is the value of a? It's negative 1 plus the value of b, it's 17. The value of c, it's plus c is equals to the value, this one, it's 15. That is my first term, 15. right? And then take this to the other side. Okay, this will just give me 16 plus c is equals to 15. Then c, you can see that c will give you negative 1, because if I take this to the other side, it's gonna give me negative 16. It's gonna be 15 minus 16, it's gonna be negative 1. Then I can just write my equation and say my equation, it's Tn is equals to an squared plus bn plus c. What is the value of a? It's negative n squared, plus what is the value of b? I think it's 17n minus 1 there. Okay, this is 17b, that and that, right? Then we wrote, this is our general equation. Last question, we need to calculate T27. What is T27? Where there's n, I need to substitute this position 27. T27 equals to negative into 27 squared plus 17 into 27 minus 1. Then what is my answer? 27 squared. Okay, it's supposed to be negative actually. Negative 27 squared plus 17 into 27 minus 1. Then my answer is minus 271. Okay, I hope you enjoyed my class. Please subscribe to my channel. Invite your friends to subscribe as well, as we will be doing more questions and making maths even more and more simple. Thank you. Bye.